Okay, hello everybody. I'm putting a video together for you for this week's material, and rather than just working through all the theory, because there really isn't much new this week, I'm just going to go ahead and put together an example for you. The topics that are covered in the book this week are on functions, and they basically look at a typical language and they walk you through all the functions that that language has in it. And so you learn about things like random numbers and how to work with math formulas and stuff like that. And then they get into user input validation, which we've already really talked about in a couple chapters ago. And they really don't add too much new to that topic. So what I thought I would do is just put together an example for you similar to what your assignment will be for this week. And that should give you enough of a running start, I think, to get this thing completed. So that's what I'm going to do, and I'll probably have to split this video into at least a couple of parts like I usually do. And so I'm going to dive down into a small basic here and we'll get started. Okay, so here is the program I'm going to be writing, and what I did is basically I lifted the requirements out of the book and just put them into what's going to be a program here, and I just put them in as comments, and I shortened them up a little bit, made them a little bit less wordy, and put them into a set of numeric steps. And so you can see here the first step. Oh, first off, this is the rock, paper, scissors game, which you probably have all played at one point or another. And usually it's against another person, and you make a fist and you count to 3, and then on the third time you both make either a rock, which is a fist, paper, which is just your flat hand, and then scissors are when you cross your fingers. Anyway, so you both do that, and then the rules are whoever wins is in step 5 there. The rock smashes scissors, scissors cut paper, paper wraps rock. And then if it's a tie, you just do it again until somebody wins. So this is the kind of thing, if you're married, you know if your wife wants you to do something you can't stand or you don't want to do, and you can try this game, and usually what happens is if you win, you have to do the dirty work, and if you lose, you have to do the dirty work. So yeah, anyway, what we've got though is a program where when the program begins, it says choose a random number from 1 to 3. Really, I should rephrase that. The computer is going to choose the random number because we're playing this game against the computer. So he starts out by choosing a number from 1 to 3, and computers know all about numbers, but they don't know what a rock is or scissors are. So what we do is we tell the computer to generate a number from 1 to 3 randomly, and then we map the number to the appropriate thing. So 1 would be for the rock, 2 for the paper, 3 for the scissors. And so step 2, we're going to assign the actual term rock, paper, or scissors based on the number they've given us. Then what we'll do in step 3 is we'll ask the user to choose rock, paper, or scissors. So they'll basically type in, one of the 3 choices, and then what we'll do is we'll display the computer's choice. We'll compare that to the user, and if they match, we have a tie, and so we have to repeat the game at that point. Otherwise, based on step 5 here, you can determine the winner, and then you can display who the winner is, and then ask the user to play again. If the user wants to play again, we jump back up to step number 1, where the computer chooses another number to get another shape or symbol or whatever. If the user doesn't want to play anymore, what we'll do then is we'll end the game by telling the user how many times the computer won and then how many times the user won. Now what I didn't put in here is that when the user chooses in step 3 rock, paper, or scissors, we're going to make sure that they enter one of the 3 values. If they enter something else, we're going to throw it out and ask them to repeat their input. The other piece of code we need to do validation on is in step 6. When we ask the user to play again, we'll expect a yes or a no, or a Y or an N. And then if they don't put in a Y or an N, we'll ask again until they cooperate. So there's a couple places in here for user input validation. And then we're going to be using the random number function, and then we're going to be working extensively with loops and with decision making. So this example really takes everything we've done to this point in these last 6 weeks or so, and it basically gives us a comprehensive program that does everything. And that really is going to be the case for most everything you write from here on forward. Your programs will almost always use loops and decision-making structures, and user input validation, and those real common tasks that you'll have to deal with are going to become second nature to you after a while, after you've written enough code. The only thing that makes life a little more interesting is when you switch into a graphical user interface, and that changes things quite a bit, because rather than being able to guide the user with text step by step, now you're throwing at them a window with a bunch of buttons and text boxes and stuff like that, and they can do whatever they want on that screen. They don't necessarily have to go in the order you expect them to go. So in terms of input validation, we have quite a bit more work to do in a graphical app as we do in a text-based app. But we're starting out simple. We don't want to get too carried away initially here. So this is where we're at, and this is the program we're going to be working with. So what I'm going to do is I'm going to take and leave this the way it is, and then I'm going to start writing the code underneath it. Okay, so what I'm going to do first of all is set up a loop, because I know that the user is going to be asked if they want to play this game again. And so what I'm going to do is set up a loop, and I'm going to say while play again is equal to quote Y quote. Now, if you think about this loop, and you're never even going to get into the loop at this point, because on line 24, play again equal to Y is a new variable. So what we need is a priming read. So what that will do is it will prime the loop so that it will enter into the loop and execute it at least one time. Now, at the end of the loop, whatever happens inside of it, we know that we're going to have to ask the user if they want to play the game again. So I'm going to put a question on the screen. Do you want to play again? Question mark. And then I'll put a Y/N here, along with a couple of chevron symbols and a space, like that. So basically they're going to be expected to type in a Y or an N. So I'm going to take and collect the response. By calling text_window.read, and I'm going to assume again that, like I said, that they have entered Y or N. Now if they enter Y, then what's going to happen is response is going to get set equal to Y. This end while on 31 will go back up to 26, and it will test play again, and if play again is equal to Y, which it will be because that's what the user typed in, it will repeat the loop. On the other hand, if they had typed an N, or really anything other than a Y, response would equal that character, or string, or whatever they typed in. And then when it came back up to line 26, play again would not equal Y. It would do what we call fall out of the loop, which would take us down to whatever came next, which line 32. Now it says that after the user decides to quit, the user can see who won the most games. And so down at the very end of the program, before we quit, what we want to do is we want to describe the number of games. Oops. Number of games that will say that you won, colon, space. Then I'm going to put a concatenation sign there, and after it, user games won. Now that variable we haven't done anything with yet. I'm just introducing it here. But user games won is something that we're going to increment every time the user wins a game. So obviously we would call this a counter. So likewise, I'm going to go ahead and, what am I doing here? I'm hitting some weird key on my keyboard for some reason. I have a keyboard with a sticky space key on it. In fact, my keyboard died over the weekend, and so I went in and got a new one. And this one has a sticky space key. So I'm getting some weird things going on here with this, so I apologize for that. Guess I gotta take a trip back to Best Buy today and get another one. Anyway, so now for some reason Small Basic doesn't always indent things. It's supposed to be smart about its indentation rules, and it doesn't always get it right. If you don't, like, if I put a while and an end while in, and I just kind of leave it there and go coding around it, sometimes it gets confused and it thinks it's still inside of a loop, and so it wants to indent. Like you see lines 33 and 34, it kept indenting them out. And I don't really know what you can do about that because the IDE here is very limited. But anyway, you might notice that when you're in here writing code. So we have kind of an outer shell at this point. We've got a priming read on line 24. And on line 25 we have our loop. Inside of that we would put our game. So what I'm going to do is put a comment here. Implement game. And then when the game is finished, we're going to ask the user if they want to play again. They're going to respond with a yes or a no, or actually a Y or an N. And it's going to come back up. Now, one thing about this program, we're making an assumption here that somebody won when we ask the user to play again. And the situation may occur where you have a tie. And when there's a tie, we have to play again. So what I'm going to do is make a comment here. If tie, comma, force user to play again. So what I'm going to do is I'm going to say if tie equals 1, then 1 will be small basic doesn't support booleans, which are true and false conditions, and so I'll have to say if tie equals 1, then I'm going to say response equals y, else I'll do that. So basically here, the game will be played on line 27. Eventually we'll put the code in for that. And then if the game results in a tie, then we're going to hard code the response to a yes. And we're not even going to ask the user if they want to play again or not. We're going to hard code the response to yes. It'll skip this else block, come back up, repeat the game essentially. If there isn't a tie, somebody wins legitimately, then tie will be equal to 0. And if that's the case, then we're going to skip the first part of the if block and go into the else part, and there we'll ask the user if they want to play again or not, and again we will get their response and come back up and go from there. So that gets us the logistics of the repeating of the game, and it gets us some of the logistics of reporting out the number of games won per user. So really the only other thing we have to do is implement the core of the game, which really is going to be starting up on line 27. So I'm going to save all of this before I get too carried away here. I'll call it rock, paper, scissors, and I've saved it. So the next step then is to go in and actually implement the core of the game itself.